On a spring afternoon in 1854, a crowd gathered inside the Crystal Palace Exhibition Hall in New York City, where a statue of George Washington had stood at the center of the Grand Dome. There was now something far less impressive to look at. A wooden platform, open on all sides, rigged between two tall guide rails, attached to a single rope that ran up through a set of pulleys near the ceiling. It looked like the kind of freight hoist you would find in any warehouse or factory. Ordinary, maybe even boring. But then a man in a top hat stepped onto the platform. He signaled to the steam engine operator, and the platform began to rise, creaking and swaying, lifting him higher and higher above the crowd below. When the platform reached its peak, the man turned to an assistant standing nearby and gave a single command: "Cut the rope." The assistant raised an axe and swung. The rope snapped. The crowd gasped. The platform lurched downward, maybe 2 or 3 inches, and stopped dead. And the man on the platform, a 42-year-old inventor from Vermont who had failed at nearly every business he had ever started, spread his arms wide and called out to the stunned audience below, "All safe, gentlemen, all safe." What nobody knew at the time was that this moment, this simple stunt put on by a struggling mechanic who had sold exactly 3 elevators the year before, would reshape every major city on Earth. It was 1854, and the idea of lifting heavy things was already ancient. Humans had been building hoisting devices for thousands of years. The Greek mathematician Archimedes is credited with constructing the first known elevator around 236 years before the Common Era, using ropes wound around a drum and turned by hand or by animals. In ancient Rome, the Colosseum used somewhere around 28 to 30 lift platforms beneath its floor, each one powered by teams of up to 8 men pulling ropes and working counterweights. The lifts carried gladiators, lions, wolves, and bears up through 23-foot wooden shafts, raising them through trapdoors directly into the arena. Each platform could support roughly 600 pounds, enough for 2 full-grown lions. 60,000 spectators watched animals appear out of thin air, never seeing the machinery or the men straining below. By the Middle Ages, monasteries perched on cliffs used baskets and rope pulleys to haul supplies and occasionally people up sheer rock faces. In 1743, King Louis XV of France had something called a flying chair installed at the Palace of Versailles, a personal elevator operated by counterweights that let him visit his mistress on the floor above without using the stairs. Even royalty wanted a lift. And during the Industrial Revolution of the 1800s, steam-powered hoists became standard equipment in mines, factories, and warehouses across Europe and America. They were everywhere. Cotton mills in Manchester, coal mines in Pennsylvania, brick factories in New York. Any building taller than 2 stories probably had some kind of hoist or crane bolted inside it. There was just one problem. The ropes broke, all the time. Hemp fibers frayed under the weight. Chains snapped under repeated stress. Iron links corroded and failed without warning. And when the rope or the chain gave out, everything on that platform, whether it was a crate of raw cotton or 3 men standing on a wooden board, dropped straight to the ground. In mines, hoist accidents were so common they barely made the newspapers. Workers fell hundreds of feet into rock shafts, and nobody was surprised. Factories lost hands, crates, and sometimes entire loads of finished goods in a single snap. The hoist was one of the most useful machines in the industrial world, and also one of the deadliest. Everyone knew it. Everyone accepted it. The ropes broke, people fell, and work continued the next morning. So, while the technology to lift things vertically had existed for centuries, nobody in their right mind would build a tall building and expect paying tenants to ride one of these machines up and down every day. The practical ceiling for any building was about 4 or 5 stories, because that was as high as a person was willing to climb a flight of stairs. The top floors of any building were the cheapest to rent, the hardest to fill, and the least desirable in every way. The ground floor was king, and that was the world Elisha Graves Otis was born into. He arrived on August 3rd, 1811, on a prosperous family farm near Halifax, Vermont. His father, Stephen, was a justice of the peace and a member of the Vermont State Assembly. His mother was Phoebe Glynn. Elisha was the youngest of 6 children, and from an early age, he was bored out of his mind by farm life. The daily chores, the repetitive seasons, the endless monotony of tending animals and mending fences, none of it held his attention. Vermont in the early 1800s was so sparsely populated that all of its residents could have fit on a single modern city block. For a kid with a restless brain, it felt like a cage. What did hold his attention was anything mechanical. When the farm equipment broke down, young Elisha was the one who figured out how to fix it, usually improving the design in the process. His favorite place was the local blacksmith shop, where he tinkered with farm implements and taught himself the basics of metalwork and engineering. He had no formal training. Everything he knew, he learned by taking things apart and putting them back together. At 19, he left Halifax for Troy, New York, and took up carpentry. He spent 5 years working in construction for his brother Chandler, but chronic health problems followed him everywhere he went. He lacked the stamina for heavy physical labor, and his body kept failing him at the worst possible times. He tried to start a grist mill along the Green River in Vermont. It failed. He converted it to a sawmill. That failed too. He built carriages for a while. That went nowhere. He hauled freight between Troy and Brattleboro in his own wagon, which kept him moving but never made him rich. Along the way, he also invented a steam-powered plow and an automatic bread-baking oven, neither of which earned him anything close to a living. In 1834, he married Susan Houghton, and they had 2 sons, Charles and Norton. 8 years later, Susan died, leaving Otis alone with 2 young boys and no reliable income. He remarried in 1845 to Elizabeth Boyd, and the family moved to Albany, New York, where he finally landed a steady job as a master mechanic at a bedstead factory owned by a company called O. Tingley. He stayed about 3 years. During that time, he invented a railway safety brake and some clever devices for improving the production of bed rails and turbine wheels. He was good at making things. He was terrible at making money, which, looking back, was either his greatest weakness or the reason history remembers him at all. In 1852, Otis moved to Yonkers, New York. A company called Mays and Burns had hired him to set up machinery in their new bedstead factory on the banks of the Hudson River. The building had multiple floors, and the workers needed a way to move heavy equipment and lumber from the ground level to the upper stories. So Otis built a standard freight hoist, the same kind that had been used in factories and warehouses for decades. A flat wooden platform, a single hemp rope, and a steam engine in the basement to wind the rope around a drum. Nothing new, nothing special. But as he stood there watching the hoist lift loads of lumber up through the building, the same thought that haunted every factory manager in America crossed his mind. What happens when the rope breaks? Because it would break. It was not a question of if, only when. Hemp ropes wore out. They frayed under repeated loading. They degraded in humidity and heat. And when one finally gave, everything on that platform would come crashing down, smashing through the floor below, destroying whatever was underneath, and killing anyone unlucky enough to be standing in the way. Otis looked at the problem the way he looked at every broken piece of farm equipment back in Vermont. Not as something to worry about, but as something to fix. He designed a simple mechanism built on the ratchet and pawl principle. Here is how it worked. A heavy spring sat compressed on top of the platform, held in place by the tension of the hoisting rope. As long as the rope was taut, the spring stayed compressed and the device stayed inactive. But the instant the rope snapped or went slack, the spring released. 2 metal pawls on either side of the platform shot outward and locked into notched teeth cut into the wooden guide rails that ran along both sides of the shaft. The platform stopped immediately. It could not fall. The concept was almost embarrassingly simple. A spring, 2 pawls, and a set of notches carved into the rails. Any competent mechanic could have built it, but nobody had. Otis finished the device, installed it on the factory hoist, and called it the safety hoist. He was so confident in the idea that he quit his job, opened a small workshop on the banks of the Hudson River in Yonkers, and started selling the device commercially. His first sale came on September 20th, 1853. It was a freight elevator. It did its job. But orders trickled in slowly. By the end of that year, he had sold exactly 3 units. The world was not exactly beating a path to his door. This is where P.T. Barnum enters the story. In 1853, New York had hosted the exhibition of the industry of all nations inside a grand glass and iron building called the Crystal Palace, modeled after the famous Crystal Palace in London. The exhibition had drawn big crowds at first, packed with the newest technological wonders from around the world. But by early 1854, attendance had dropped sharply. The novelties from the previous year were now old news, and Barnum, who had taken over management of the venue, needed something dramatic to bring people back. He published an open letter to the directors of the Crystal Palace Association in April, promising a grand re-inauguration with new exhibits and operating specimens of nearly every great invention. Otis approached him with a proposal. He would demonstrate his safety hoist in the most public, most theatrical way possible. He would stake his own life on the device in front of a live audience. Barnum, who understood spectacle better than anyone alive, agreed immediately. Workers removed the George Washington statue from the center of the exhibition floor and erected Otis's hoist in its place, right under the massive 100-foot dome of the Crystal Palace. On May 30th, 1854, the demonstration began. Otis rode the platform up to full height, standing in plain view of a large crowd, wearing a top hat and his best clothes, with nothing between him and the hard floor below but air and a single rope. The crowd knew what hoists were. They knew how dangerous they were. Every person in that room understood that if the rope broke, the man on the platform would fall and almost certainly die. Otis gestured to his assistant, who raised an axe. One swing, the rope split, the crowd screamed, and the platform dropped, lurched downward a few inches, caught and held. Otis stood perfectly still, then announced in a calm voice that echoed through the hall, "All safe, gentlemen, all safe." He repeated the demonstration multiple times over the following weeks, cutting the rope again and again, letting the safety device catch him every time. It was pure showmanship, the kind of stunt that puts an invention into the public imagination. But here is the strange part. Almost nobody covered it. Only 2 publications, Scientific American and the New York Daily Tribune, reported on the demonstration. The Tribune mentioned that the inventor would occasionally cut the rope as he rode the platform up and down, almost as a footnote. The wider press barely noticed. The demonstration that would later be called one of the great moments in architectural history went almost completely unrecognized in its own time. Sales picked up, but slowly. Otis sold 8 elevators in 1854, 15 in 1855. These were freight units, not passenger machines, and the buyers were factory owners and warehouse operators, people who already used hoists and simply wanted safer ones. The real breakthrough, the thing that would prove the safety elevator, was not just a better freight hoist, but a technology that could change how human beings lived and worked, came 3 years after the Crystal Palace demonstration. On March 23, 1857, Otis installed the first safety elevator designed for passenger service. The location was the E.V. Howwout department store at 488 Broadway in Lower Manhattan, a 5-story cast-iron building at the corner of Broadway and Broome Street. The building itself was a work of art designed by architect John P. Gaynor in an ornate Italianate style modeled after a 16th century Venetian library, with elaborate cast-iron facades provided by Daniel Badger's Architectural Iron Works. The Howwout store sold fine china, cut glass, silverware, and chandeliers, and counted among its customers Mary Todd Lincoln, the First Lady of the United States. Its owner, Ida Howwout, was no fool. The building stood under 80 feet tall, 5 stories. Any healthy person could walk up 5 flights of stairs without much trouble. Howwout did not need an elevator. He wanted one because he understood that the novelty would draw curious customers through the door, and that once they were inside, they would stay to buy merchandise. And he was right. The elevator cost $300 which is roughly $10,000 in today's money. It was powered by a steam engine bolted to the basement floor. It traveled at about 2/3 of a foot per second, taking roughly 40 seconds to crawl from one floor to the next. Customers could ride it for a fare of 10 cents per floor. The machine was slow, loud, and a little terrifying. Most people who visited the store on opening day still took the stairs anyway. They did not yet understand what they were looking at, but some people rode it. And they rode it because they trusted it would not kill them. That trust, however faint, however tentative, came directly from the spring-loaded mechanism Elisha Otis had built in a factory in Yonkers 5 years earlier. For a while, things actually seemed fine. The How-Out elevator drew crowds. Orders started coming in from other buildings. The company was growing, but the business side of things was still a struggle. Otis had named his operation the Union Elevator and General Machine Works, a mouthful that said everything about his personality and nothing about marketing. In 1858, the company nearly went bankrupt. Otis kept it alive through the goodwill of his creditors, surviving on promises and reputation while the account books bled red. He was a brilliant mechanic and a relentless inventor, but he had no gift for the business side of the operation. His son Charles later admitted that his father was extraordinarily skilled in engineering, but had absolutely no talent for commerce. The pattern of his whole life repeated itself. One ingenious invention after another, and not a dollar to show for any of it. Otis kept working anyway. In January of 1861, he finally secured a patent for his safety elevator design. United States Patent, number 31,128. 4 months later, on April 8, 1861, during a diphtheria epidemic sweeping through Yonkers, Elisha Graves Otis died at his home. He was 49 years old. He left behind an estate valued at $5,000 and debts, totaling $8,200. No obituary ran in any major newspaper. The man who invented the device that would make skyscrapers possible died, broke, and almost unnoticed. His sons did not let the story end there. Charles and Norton Otis took over the company immediately after their father's death. They had grown up in the workshop, trained by their father since childhood, and they understood both the machines and the market in ways their father never quite managed. Where Elisha could build anything but sell nothing, his sons could do both. They paid down the debts. They built a new factory. In 1861, Charles personally wrote the industry's first service agreement, a contract in which he promised to assume the entire charge and responsibility for maintaining a client's steam-powered elevator at a cost of $780 per year. In 1864, they rebranded the company as Otis Brothers and Company. They improved the elevator designs, developed new models, and pushed aggressively into new markets. In 1867, the company won a gold medal at the Paris Exposition. By the end of that decade, riding the post-Civil War building boom, the business was thriving. And then the real transformation began. In 1870, the Equitable Life Assurance Building opened at 120 Broadway in Lower Manhattan. It stood 7 stories tall, roughly 130 feet, and it was the first office building in New York designed from the ground up to include passenger elevators. The Otis Elevator Company built 2 hydraulic elevators for the building. For the first time in history, tenants on the upper floors paid higher rents than tenants on the lower floors. Think about that for a second. For thousands of years, the ground floor was the most valuable real estate in any building. The higher you went, the more stairs you had to climb, and the less anyone wanted to be there. The elevator flipped that equation overnight. Suddenly, the top floors had better views, better light, better air, and more privacy. The penthouse went from being the cheapest space in the building to the most expensive. One machine inverted an entire economic model that had been in place since the first humans stacked stones on top of each other. The same ironic detail that made the upper floors desirable also made the buildings themselves taller. Because if the elevator could carry tenants comfortably to the 7th floor, why not the 10th? Why not the 20th? The answer used to be simple. You could not build that high with traditional brick and stone. The walls at the base of a 15-story masonry building would need to be impossibly thick to support the weight above them, leaving almost no usable floor space on the ground level. But in the 1880s, a second innovation arrived that paired perfectly with the safety elevator: steel frame construction. In 1885, the Home Insurance Building opened in Chicago, designed by architect William LeBaron Jenney. It stood 10 stories tall, 138 feet, and it was the first tall building supported by a structural steel frame, rather than load-bearing masonry walls. The steel skeleton carried the weight, the exterior walls were just a skin, and inside the building, 4 Otis elevators moved tenants up and down between floors. The age of the skyscraper had arrived, and without the safety elevator, it could not have happened. You can build a steel frame as tall as you want, but if no one can get to the 14th floor without climbing 14 flights of stairs, no one will rent space on the 14th floor. The elevator did not just make tall buildings possible, it made tall buildings profitable. From that point forward, the race was vertical. In 1889, the Otis Elevator Company installed elevators in the Eiffel Tower in Paris, solving the engineering challenge of carrying visitors up through the tower's curved iron legs. In the early 1900s, New York erupted skyward. The Flatiron, building in 1902, standing at the sharp intersection of Broadway and Fifth Avenue, a wedge of steel and limestone that seemed impossible at the time. The Singer Building in 1908, 47 stories, the tallest building in the world when it opened. The Metropolitan Life Tower in 1909, 50 stories, topped with a clock visible from blocks away. The Woolworth Building in 1913, 58 stories and 792 feet tall, nicknamed the Cathedral of Commerce, with a lobby covered in marble and gold leaf mosaics that looked like the inside of a cathedral. Every single one of them ran on Otis elevators. You could not have built any of them without the machine that carried people to the top. The company that Elisha Otis had founded in a small workshop on the Hudson River, the company that nearly went bankrupt while he was still alive, was now operating in buildings that would have been physically impossible without his invention. And the technology kept evolving. The early steam-powered elevators gave way to hydraulic systems in the 1870s, which could move faster and reach higher. The industry also established its standard for elevator response time during this period. No more than 30 seconds between pressing the button and the car arriving. And that standard remains the same today. Then came electric elevators in the 1880s, first built by Werner von Siemens in Germany in 1880 and quickly adopted worldwide. Electric motors removed the last practical barrier to building height. Hydraulic elevators needed a piston beneath the shaft that was as long as the building was tall, which meant you needed to dig a pit as deep as the building was high. For a 12-story building, that was manageable. For a 50-story building, it was absurd. You would need to drill 50 stories into the bedrock of Manhattan before you could build 50 stories above it. Electric traction elevators solved that problem entirely. They used cables and counterweights driven by a motor at the top of the shaft, and they could go as high as the building itself, no pit required. The Otis Elevator Company developed an improved gearless traction machine that became the industry standard, and it powered the vertical expansion of cities for the next century. The deeper story here is not really about machinery at all. It is about what happens when you remove a constraint that everyone has accepted as permanent. Before the safety elevator, cities grew outward. If you needed more space, you bought more land. Streets stretched wider, neighborhoods sprawled. The footprint of a city was determined by how far a person could reasonably travel on foot or by horse. But after the safety elevator, cities could grow upward. A single city block that previously held one 4-story building could now hold a 40-story tower with 10 times the floor space. Population density exploded. Manhattan, which could only hold so many people when every building topped out at 5 stories, could suddenly accommodate millions in the same square mileage. The same piece of land became 10, 20, 50 times more valuable because you could stack that many more floors of rentable space on top of it. Department stores in increasingly crowded cities could build up instead of out, adding floor space without buying more land or paying higher ground-level rents. Luxury apartment buildings started advertising elevator service as a selling point in the 1890s. The concept of the high-rise apartment, an entire community stacked vertically with shared hallways and a single lobby, became possible and then normal. Real estate economics, urban planning, architecture, commuting patterns, even social class, and where people chose to live, all of it shifted because one man figured out how to keep a wooden platform from falling. And the company Elisha Otis left behind is still running. Otis Brothers & Company went through several name changes over the decades. It became part of United Technologies and was eventually spun off as an independent, publicly traded company in 2020. Today, the Otis Elevator Company operates in more than 200 countries. It maintains a fleet of over 2 million elevators and escalators worldwide. The company moves an estimated 2 billion people every single day. 2 billion every day. On machines that trace their lineage directly back to a spring, 2 pawls, and a set of notches carved into wooden guide rails by a chronically sick mechanic from Vermont who could not make a sawmill turn a profit. The E.V. Howout building still stands at 488 Broadway in Manhattan. It is still 5 stories tall. It is still a designated New York City landmark. And it sits quietly surrounded by the skyscrapers that the little steam-powered elevator inside it helped make possible. Elisha Otis did not invent the elevator. People had been lifting things vertically for over 2,000 years before he was born. What he invented was the reason you are willing to step inside one. The safety brake, the device that catches you when the rope snaps, the thing that turns a death trap into a convenience. And that, more than any steel beam or concrete foundation, is what built the modern city. The next time you step into an elevator and the doors close and you feel that slight lurch as the car begins to rise, you are standing on top of an idea that a broke, sick, stubborn inventor from a Vermont farm refused to let go of. 170 years later, the platform still holds. If this story surprised you, hit subscribe and leave a comment telling us which everyday invention you think deserves its own documentary. And if you are already subscribed, tap the like button so more people find this video.